Every night you look up at the moon and think nothing of it. But here is something that will change that forever. Scientists have just confirmed that the moon has been quietly pulling water away from Earth for billions of years. The proof existed, all along. We just were not ready to see it. For 45 years, this question haunted planetary scientists. Could Earth actually be losing water to the moon? Apollo missions hinted at it. Decades of research circled around it. Now, confirmed. Data has finally answered it. In this documentary, we break down the full science, the breakthrough discovery, and what it genuinely means for the future of life on Earth. The year was 1969. Astronauts Neil Armstrong and Buzz Aldrin stepped onto the lunar surface and changed human history forever. But beyond the iconic footprints and the famous photographs, they brought something back that quietly puzzled scientists for decades: moon rocks. These samples were not just lifeless gray stones. When researchers analyzed them under careful laboratory conditions, they discovered microscopic traces that suggested past interaction with water-bearing particles. At the time, nobody could explain this with certainty. The moon was considered completely dry, an airless and waterless rock drifting silently through space. So, where did these traces originate? Some researchers proposed a bold hypothesis. Perhaps water molecules from Earth's own atmosphere were escaping into space and eventually reaching the moon's surface. It sounded almost unbelievable. Earth losing water to the moon? The idea felt more like science fiction than serious planetary research. But the question refused to disappear. Through the 1970s, 1980s, and 1990s, scientists kept returning to this puzzle. Instruments became more advanced. Space missions gathered richer data. Each new finding added another small piece to a picture that was slowly becoming undeniable. The Apollo era had unknowingly planted a scientific mystery that would take nearly half a century to fully resolve. Researchers who dedicated their careers to atmospheric science and lunar geology held on to this question through professional skepticism, limited funding, and technological constraints. They were patient, and, eventually, the universe rewarded that patience with an answer nobody could argue against. The real investigation was only just beginning. To understand how the moon collects Earth's water, you first need to understand how Earth loses it. This process is not visible to the human eye. It happens far above the clouds, in the outermost layers of our atmosphere, where the rules of physics operate very differently. Earth's atmosphere is divided into several distinct layers. The highest of these, called the magnetosphere and the exosphere, are where water molecules can become vulnerable. When sunlight strikes water vapor in the upper atmosphere, the energy breaks apart H2O molecules into their basic components, hydrogen and oxygen ions. These charged particles do not simply float around, they respond to Earth's magnetic field lines and begin traveling along invisible paths through space. Most of these ions eventually fall back toward Earth, recaptured by gravity. However, a portion of them escape entirely. Scientists call this phenomenon atmospheric sputtering and ion escape. It is a slow, continuous, and completely natural process that has been operating since Earth formed over 4 billion years ago. Think of it this way. Imagine Earth as a bathtub filled with water and a very slow, nearly invisible drain. Every single day, a tiny amount trickles out. On a human timescale, this loss is completely insignificant. But across billions of years, the volume becomes genuinely meaningful. This is not a future threat. It is an ongoing reality. Earth has been leaking water into space for as long as it has existed, and the moon has been positioned perfectly to catch some of it. While Earth slowly releases water ions into space, the moon has been quietly waiting. Its position, its lack of atmosphere, and its unique surface conditions make it a remarkably efficient collector of exactly the kind of particles Earth releases. Unlike Earth, the moon has no significant global magnetic field. It has no thick atmosphere to deflect incoming particles. This means that whatever travels through space in the moon's direction lands directly on its surface with very little resistance. Solar wind particles, cosmic dust, and yes, ions escaping from Earth's atmosphere all make contact with the lunar surface constantly. Spacecraft data has been central to confirming this connection. Japan's Kaguya lunar orbiter detected oxygen ions near the Moon that carried a specific chemical signature. These were not originating from the Sun. Their isotopic profile matched Earth's atmospheric composition almost precisely. NASA's ARTEMIS mission, designed specifically to study the lunar environment, gathered additional measurements, showing that during certain orbital alignments, Earth's ion tail passes directly across the Moon's path. The permanently shadowed craters near the lunar poles are particularly significant. Temperatures in these regions drop so low that water ice can remain stable for billions of years without evaporating. Scientists now believe these craters function as ancient storage vaults, preserving water that arrived from multiple sources, including our own planet. The Moon is not stealing Earth's water through any dramatic cosmic event. It is simply collecting what drifts naturally in its direction. Patient, silent, and utterly indifferent, a collector operating on a timescale humans can barely comprehend. For decades, the hypothesis that Earth was supplying water to the Moon remained exactly that, a hypothesis, compelling, supported by indirect evidence, but never definitively proven. That changed when a combination of advanced instrumentation, improved data analysis, and determined scientific collaboration finally produced confirmation that the research community could not dismiss. The breakthrough came through the careful study of ion composition data gathered by multiple spacecraft over several years. Researchers cross-referenced measurements from different missions and identified a consistent repeating pattern. During specific phases of Earth's orbit, when the Moon passed through a region called the plasma sheet, a trailing extension of Earth's magnetosphere, the concentration of Earth-origin oxygen and hydrogen ions on the lunar surface measurably increased. This was not coincidence. The pattern was too precise, too consistent, and too chemically specific to be explained by any other source. The isotopic ratios of these ions matched Earth's atmospheric fingerprint with a level of accuracy that eliminated alternative explanations. Peer-reviewed studies published in respected journals laid out the evidence methodically. Independent research teams in different countries analyzed the same data sets and reached identical conclusions. The scientific community, which demands extraordinary evidence for extraordinary claims, reached consensus. For some researchers who had spent entire careers investigating this connection, the confirmation was deeply personal. One scientist described the moment as finally closing a chapter that Apollo had opened. 45 years of patient investigation had produced an answer that was, in hindsight, written in the data all along. The Moon carries Earth's water. That is now established fact. The natural question this discovery raises is straightforward. Should humanity be worried? Is Earth genuinely running out of water because the Moon is drawing it away? The scientific answer is reassuring, but it comes with important context worth understanding clearly. On a human timescale, even across all of recorded civilization, the rate of water loss to space is completely negligible. Earth holds approximately 386 billion cubic kilometers of water. The amount escaping into space annually represents a fraction so small it would take millions of years to register any measurable difference in ocean levels or atmospheric moisture. However, the long-term picture is different. Over billions of years, this process has cumulatively removed a significant volume of water from Earth's hydrosphere. Planetary scientists believe early Earth may have possessed substantially more surface water than it does today. Atmospheric escape is one of several mechanisms responsible for that gradual reduction. The comparison to Mars is particularly illuminating. Current evidence strongly indicates that Mars once hosted liquid oceans and a water-rich atmosphere billions of years ago. Mars lost its global magnetic field early in its history, which dramatically accelerated atmospheric escape. Without that protective shield, solar wind stripped away Martian water at a rate far exceeding what Earth experiences today. Earth's magnetic field remains our primary defense against rapid water loss. As long as it stays strong, our planet retains its life-sustaining hydrosphere. This discovery is not a warning about imminent crisis. It is a reminder of how fragile planetary conditions genuinely are across cosmic timescales. This discovery does not exist in isolation. It connects directly to some of the most significant scientific and exploration endeavors currently underway, and it reshapes how researchers think about water, life, and planetary survival across the entire solar system. NASA's Artemis program is actively working toward returning humans to the moon, with long-term plans for sustained lunar presence. One of the most critical resources for making that possible is water. Lunar water ice, confirmed in permanently shadowed polar craters, could be processed into drinking water for astronauts and broken down into hydrogen and oxygen for rocket fuel. This would fundamentally reduce the cost and complexity of deep space missions. Here is where the discovery becomes extraordinary on a human level. Some portion of that lunar water ice originated from Earth. Water that once flowed in ancient rivers, filled prehistoric oceans, and sustained early life on this planet may now be frozen inside moon craters, waiting to sustain future astronauts on their way to Mars. Beyond practical applications, this finding advances the scientific understanding of how planets across the universe interact with their natural satellites. It suggests that water transfer between a planet and its moon may be a common phenomenon in other star systems, potentially relevant to the search for life beyond Earth. The moon is not simply a lifeless rock reflecting sunlight. It is a repository of Earth's own history, holding physical evidence of our planet's evolution across billions of years. Every crater filled with ancient ice is, in a very real sense, a piece of home. That is the full story. From Apollo's unanswered questions to confirmed scientific proof, this 45-year journey reveals something profound. Earth and the moon are not separate worlds. They are connected by an ongoing exchange that has shaped both of them since the beginning. The moon does not just reflect our light, it carries our history. If this documentary shifted your perspective, share it with someone who would never expect the moon to hold Earth's water. Subscribe for more science documentaries that go beyond the surface, and drop a comment below. Does knowing this change how you see the moon tonight? Watch our next video to keep going deeper.